Hey, good morning, all. Welcome to the Common Good Podcast. It's a Thursday. We get to talk with astrophysicist Paul Wallace, November 9th. And Paul, we were just chatting before we came on, and you happened to mention that it was the day after your wife's birthday.
That's right.
Well, happy birthday.
And it's actually my late father's birthday today.
Oh, well, happy birthday.
We used to all get together and have, parties with both of them back in the day.
And then we're all reminded that someday that's going to end.
That's it.
Good morning, everyone. If there's someone you love who has a birthday soon, someday you won't.
You are going to die.
It's still their birthday, I guess. They're just not still alive.
It's still their birthday.
Yeah, because really what we do with birthdays is we really treat them like this is we're happy you're alive day.
Exactly.
Right. Like after someone has passed on, which both my parents have, their birthday is still meaningful, but the whole point was you were born and you're alive. I mean, afterward, it's sort of it's like it's like a memory day. Well, a couple of days ago, we did when we did the Tuesday morning podcast where the conversation partner is Rob Ryersey. It was his wife's birthday.
Dang.
Just like 48 hours ago. Yeah.
Wow.
I get it. Everybody has a birthday. It's really not that big of a deal. But it's kind of interesting that in the same week, back-to-back guests have wives with birthdays right around the podcast time.
These things happen, yeah. So, I mean, it's actually kind of funny. If you get like 50 people in a room, I can't remember the odds, but if you get 50 people in the room, it's super likely that two of them have the same birthday.
Really? Like those are the numbers? Like 50 people?
Yeah, like 50 people, and the odds are it's like 70 or 80% that two of them have the same birthday. I could work it out, but I can't remember the exact number. Be clear, I'm not saying that you just guess a day like November 15th.
Yes.
The issue is that two people will have some pair will have the same birthday sometime in the year.
Yeah, that's even more unbelievable that rather than just picking a day like November 15th, you're
right.
Like, no, July 5th, if I'm in a room of 50 people, there's some other person over there that not me.
No. The point is two people, some two people will have the same birthday.
How do you figure that out with math, by the way? What?
we could do it the next podcast.
Would that be a dream?
I'll set up my whiteboard back here and step everybody through it.
Don't be teasing me now, Paul. Don't you be saying this stuff and then not do it.
I will do it if you want me to. I absolutely will do it.
Delightful. I mean, look, there's this constant joke in culture that's, where the person says, "Hey, I was told there was no math in this," right? Whatever the thing is. And my math skills are very rudimentary. I mean, I'm sure forgotten all the algebra, all the geometry that I ever learned.
Yeah.
40 years ago. I am sure it is gone. There would be no, if I try to dig deep back into the recesses of my mind without some level of hypnotic help, there's no chance I'm pulling that stuff out. And that's not even advanced math that you're talking about. Like what you're talking about.
Probability.
Math probability. I mean, I love the notion of probability. I feel like I operate, my understanding of the world based on probabilities. But I don't know how people work it out with numbers and symbols.
I could show you.
You fancy math people don't even use numbers, right, for that stuff. Like
I mean, occasionally. I mean, you have to use numbers occasionally, but mostly no. Mostly we use.
God.
There's all kinds of phenomenally interesting things. Like have you heard this one that every time you breathe in, you're breathing out. You're breathing in an air molecule that Jesus breathed.
I have,
for example, or any historical figure that you pick.
Yeah, and some matter with some of your cells were the cells that were those people, like something like that. Yeah, I've heard that. That's probability stuff that they do. That's not just like
it's probability.
Huh.
Yeah.
Well, chances are it's true. I don't know.
It's chances are it's true. In all probability, it's true.
Yeah, yeah, in all probability. Well, hey, I'm Doug Pagitt. This is astrophysicist, pastor, professor Paul Wallace, and birder. So, Paul, we like to check in on a couple of things. Of course, how's the weather? 38 degrees right
Yeah,
now in Minneapolis. Going to be 46. Going to be sunny, lovely fall day. Leaves still on the tree. He's here in the
amazing.
greater Twin Cities area. How are things there in
Good.
Decatur,
Leaves on the
Georgia?
trees, of course, down here in the south. They're basically at the peak of their color right now in Atlanta. They're they're at the very peak, and within a week and a half or so, they'll all be down.
Do people travel there to, like, here people say, like, if you're going to head up north, that's how we talk about it. If you're going to head up north to see the colors, this is the weekend or that's the weekend. Is that true in Georgia? Is it like
Yeah. We head
one
up
year
to
weekend?
what we call the mountains, North Georgia mountains. We're four
Mhm.
thousand feet high. Yeah. This is about the time. Late October, early November is the time, and all the
Yeah.
hotels get swamped up there. There's traffic. It's a
Yeah.
bunch of nonsense.
There it is. There it is. Yep. Same thing. Hey, do you know this idea that, I guess it's not an idea, it's just sort of a fact of nature that people use to talk about other things, that tree leaves are now in the fall their color, the tree's true color, and in the summer that color is covered up by the chlorophyll that it's producing. That's why they're green.
I've never heard that.
So,
But
and
I but arguments like that always make me like statements like that make me always wonder like what are you talking about? Like what do you mean what is its true color?
well, all right.
You know what I mean?
So I've heard it usually as like a sermon or funeral uh, illustration.
Yeah, okay.
So it would be, and as that leaf for that year is coming to the end of its life, its true colors are actually showing.
Got you.
They've been covered up by the growth and all the chlorophyll.
I
But
see.
this is and look how beautiful.
Well,
So it was with Ed. And in the final days of Ed's life, I hope your father's name wasn't Ed. And in his
no.
final days of his life, the true colors as Ed reached the end of his life were starting to show. And may it be with all of you that your true
Yes,
colors will
right.
come through. And
Right.
whatever you've been using to cover it up, may you glisten in the sun. Yeah, right. So this
Got
kind
you.
of thing.
Yeah. Right. I follow. Yeah. Well, if that's true, then I got a stand of hickories out here that are just dynamite colored. Their true
And,
colors are bright gold, yellow gold. I mean, super bright.
and
Amazing.
and and maybe I just have, late 1980s true colors running through my mind, but I
Mm,
kind of like the idea, of the beauty of the diversity of nature. And sometimes in some parts of the world, always, and some in certain times of the year where we live, the green color. I know there are variations on green, but it kind of all looks the same.
it's all the same stuff.
But then
Yeah.
you get this period of time where even on a tree and the upside and the backside of a leaf and everything, I mean, that's just kind of
Yeah.
cool, right? There's like
It
a
is
lot
kind of
more
cool.
diversity that we don't always see, and
Yeah.
sometimes you see. Hey,
Yeah.
speaking of that, you've been on a little pursuit to see the birds in every county in Georgia.
Yep.
Any bird watching updates that we need to
I've
know
done a
for those
little
keeping
bit. I
track at home?
went last weekend to a county called Washington County, which is nowhere near any interstate. That's that's what I've been doing lately. I've been seeking out the counties that are not would nothing particular to draw you, you know. And so I went to Washington County, went to a state park there, and uh, and I birded for about 4 hours last Sunday morning. It was my church.
Wow.
I about once a month I skip church and go birding. So that's what I did. And all the winter birds are here. They've all shown up. I'm letting you know that they've all migrated and they've all landed at least here they've landed where they're supposed to. So
Really?
yeah,
The winter birds are in place. Everybody's gone
they're
over there.
here. The summer birds are gone and the winter birds are here. Yep,
Huh.
yep.
Is
Out with
that
the
is
old
that
in with the new.
exciting for a birder? Is this an
It's
exciting time?
I would say reassuring. With all the climate crisis and all that, this is
Okay.
reassuring
Yeah.
to see it, and it is exciting because it's always nice to see birds you hadn't seen since April.
Mhm.
It's always
Huh.
nice to see those.
Did you
See them.
see a different birds than you have seen in other years? Like, was it like, oh, there's the
No, I didn't really see. I did see one bird that I think was either lost or a very late migrator because it was really not supposed to be there.
Oh,
It's called a black and white warbler. It's just a little bird, four and a
yeah.
half, 5 inches long. Looks like a little referee, little stripes, little black and white stripes, like a little zebra bird.
Huh.
And I saw one of those, and I was really surprised to see one of those because usually they disappear mid-October, something like that. I mean, they're gone after mid-October. They pass them through. They're migrants here, but this one is either
Where are they
lost
heading?
or south to South America, mostly.
It just still
Central
blows.
America, Central South America.
Just blows my mind still that that little bitty bird
Yep,
is going
I
to fly from
know.
wherever,
I
let alone
know.
Georgia,
Yeah,
to, I don't know, Venezuela.
yeah. Some of them go that far. I'm not sure if the. I suspect that these black and white warblers might actually go to southern Florida. There might be some in southern, who stop there,
Okay. Yeah.
but certainly some of them cross over the Gulf too. Yeah,
Amazing. Just amazing.
amazing,
Hey,
incredible.
you know what else is amazing, Paul, is this headline that I saw in Futurism, and people, if they've paid attention at all to the title of the live stream podcast for the Vote Common Good podcast, might not be surprised. But in Futurism, there's an article that says, should astronauts be allowed to eat each other if they're starving? And there's a glorious photo of an astronaut. I mean, I just doom scroll through the news like everybody, and I have an
Of
astronomy
course.
section as a non astronaut would, or
Yeah.
non astronomer would. And there's the question: should astronauts be allowed to eat each other
This is
if they're starving?
this sort of in a Donner Party kind of situation, but in space, I'm guessing.
100%, yes. Specifically,
Yeah.
a book written about what happens. So, just what happens if Elon Musk gets out of his own way, and we end up with a colony on Mars? And what happens if
Gets
there
out of his
becomes
own way.
a problem, and the packets of food get open or whatever,
Right.
however they're going to live
Right.
up there?
Right. There's not a lot of
Uh,
arable soil on Mars. Yeah, you can't grow stuff.
do we end up in a cannibalism situation? Uh,
And
and
is that okay?
yeah, that's really the thing about the question. Like, should they be allowed to? Like, what are you talking about? Should they be? If
Yeah,
you're in
yeah,
a
yeah. I,
situation
I I think
where,
people in that situation are not like looking up the rule book. Oh,
yeah,
this is against policy. We can't do it.
yeah, we're
Uh,
starving. Ed died over here, but his true colors were really quite glorious in the final moments.
we're
And now
back
what
to
are we
we're
going
back
to
to
do?
back to Ed again, huh?
Yeah, back
Yeah.
to Ed. uh, so I don't know. This just there's something about the fundamental base, like, evolutionary questions that people love to combine with future
Oh,
endeavors,
yeah.
especially in like futurism, right? Like, people love this stuff. Like, sure, we're ultimately going to get our bodies off of this planet, and not just having people live in lower atmosphere up in the space station, but people might be up on the moon for long
Yeah.
periods of time, or maybe we're getting up on Mars. Like, that stuff is a coming. But do you think we'll eat each other when we're there? Do you think?
That's what people really want to know.
Yes. Like, there's almost no sense of progress that is exciting to the, I don't know, like, the imagination of
Yeah.
people, as, but will we turn to some base level of
Right.
morality
Right.
violation that we
Yeah.
didn't
Right.
do?
Right.
What
We
what
can
what
achieve
is
all
it?
this stuff, but are we still basically just wild animals that would just
Yes.
I think that's the thrilling sort of combination. This brilliant technological achievement paired up with our base level, you know, wild animal nature.
Yes. Yes.
Yeah.
That, like, we do have those canine teeth, we still
Oh, we
have
got them.
some
Yeah. Yeah.
connection to, do any, okay, this can get a little morbid. Do any animals eat their same kind?
Yeah. I don't know if they eat them like as a regular routine,
Yes.
but yeah, I mean, mother lions have been known to eat their cubs.
This is the darkest Thursday podcast we have ever done.
You know what we should do, Doug? We just embrace that and go with it, just today and get it out of our systems, and then we'll be fine next time.
Should they be allowed to, though, Paul? Should they? Should
That's the funny thing about it. It's like, oh,
is that okay? So what?
I mean,
Grand,
it is funny that they put the phrase "be allowed." They could have just asked the question, "Should astronauts eat each other if they're starving?" But
yes,
they didn't ask it that way. They said, "Should they be allowed to?"
yeah. Should it be in the manual? But back to this,
Exactly, exactly.
back to the mother lions. Do you know? Do people who are making their guesswork on why animals do what they do? Which I say that very pointedly, by the way, because sometimes, uh, zoologists and biologists and people that study human and animal behavior do a lot of anthropomorphizing about the motivations and rationale for why any creatures behave the way they do. There's a lot of projection going on.
Sure.
When they're doing this, are they like, look, if the mother lion doesn't consume or eat that cub, something worse would happen, like it's preventing some disease from spreading or
You know,
something along those lines? Do you have any idea? Because
I
now
have
I'm that's gonna
no
shake that thought all day. It's just
no
gonna be
clue. I have no clue. And other animals, these might be insects. I can't remember. I don't know if insects count, but
well, yeah.
I mean,
Love and Life Always says female tarantulas eat their mates sometimes after mating.
yeah, yeah. And I
Good
know that
lord.
it's true for manises too. Also, um, I mean,
Like
I don't know
praying
if you've ever
mantises?
praying mantises. Yeah,
Uh-huh.
yeah. Um, the insect world is just a nightmare. It really is. There are insects that eat their own mothers, like when they're born. Right after they eat their.
Oh,
It's just this,
huh.
and yeah, it's absolutely off the chain. So,
Oh
uh,
boy.
yeah, basically, the way I just evolution will basically try anything once. Like it's
Once.
evolution throws everything up against the wall, everything, and
Sure. Yeah.
some things stick. One thing out of 1,000 sticks. But the ones that fail just fail spectacularly. And
Yeah, and then we don't really know about them. All right, well let's get our minds out of the realities of biology and up into the beautiful sky of lifeless stars. That
before we do that, I will put in my vote that I think that astronauts
oh,
should be allowed to to eat other astronauts.
great point.
That's my vote. In other
Absolutely,
words, I'm
people
just
need to
saying
vote on this.
I'm just saying that if I had to put in on that, I would say. I mean, I'm not like wild about it. I don't think it's a great idea, but I think that essentially, who am I to judge at this point? Do you know what I mean? I mean, if somebody had done that in order to stay alive, I would not point out the fact that it might have been against company policy. I would let it
I
go.
would love people to vote in Facebook or on YouTube their with their comment, their vote. Um, I guess now I'm thinking about this much more. That, in fact, before we came on, Paul said to me, "Hey, I didn't have a chance to read that article," and I said, I didn't read the article really either. I mean, I like skimmed it. I didn't really care about the article. The
Yeah, yeah,
question in the headline
yeah.
was what was interesting, and I guess I was assuming, and right now I'm challenging my own assumptions on this this crisis that I've created in my mind to answer this question, that the astronaut had died of something else, as opposed
Right.
to we've run out of food.
Oh yes,
Let's go
that's.
talk to Ed, you know?
Eddie drew the short straw. I'm sorry.
Sorry, Ed, you do
Yeah.
have the fleshiest flesh.
No,
Uh,
no, I would not say that. I would assume that one astronaut that there's not murder happening. Yeah, when I
mhm.
said that I would give them the green light to do that, my assumption was that the person in question had already, you know, shuffled off this mortal coil, so to speak.
Shuffled off this
Shuffled
more.
off this mortal coil. Yeah, it's from Shakespeare.
I'm jotting that down. I may change the title of this when it goes up on YouTube to "Shuttle Off This Mortal Coil Talk." That's pretty good and dark. All right. Well,
Shuffle,
I don't want to
shuffle,
think about Astro
shuffle. SHUFFLE. Shuffle off.
Shuffle. Yeah. Did I say shuttle?
Shuttle. You said
Yeah,
shuttle.
I was in the shuttle
Mm, yeah.
thought. Hey, can humans even eat each other? I thought there were like toxins and like that doesn't work. Like
I
people
don't
get
know.
sick and stuff. There's not nutrients in there.
I,
There's not
I
meat. That's okay. Yuck.
that's not a
All right.
place I go very much in my mind. So I
I'm
don't.
done.
Yeah.
I'm so sorry to anybody who's now
Ever-
like, I don't know why anyone watches
well,
this
I
podcast,
don't know.
listens to this
I don't know. Our
podcast, or
numbers of
does this
viewers have
podcast.
gone up in the last 5 minutes. I think this might be a very appealing to people.
Well, yeah. All right. Hey, let's talk about something more starry-eyed. And
Yeah.
that is the vanishing stars, Paul. Vanishing stars. When I sent you this headline, which reads, "Hundreds of stars have vanished without a trace. Where did they go?" It's the headline. You wrote back and said, "Oh, I love that image. I use it in my class all the time."
Yeah.
So now I'm like, what you talking about, Willis? I don't understand this. What do you mean? Where did these go? uh, and they're missing in traces. What's happening here?
Well,
Why are stars vanishing and where are they going?
well, there's a couple of things happening here, and it turns out that the photograph has nothing at all whatsoever to do with the headline.
Wow.
That's the first thing you got to know. The picture itself is the most striking example of something called a Bach globule, which is a hilarious name. Basically, it's a cloud of dust. Okay.
Well, will you describe the photo, since you know it well, for the
Yes.
people who aren't looking at their
Basically,
screens?
it's what you have is a field of very bright stars, very densely packed stars, and right in the middle of the field of stars, there's this big empty space.
Like a
It looks
kidney
like
bean shape, yeah.
it's skinny bean shape, and it looks like there's no stars there. But that's not true. There are stars there. It's just that this kidney bean shaped black thing is a cloud of dust obscuring the stars in the background. There are stars behind it, but you can't see it because the dust absorbs the light from them. So
All
it's a
right. So
cloud.
we do have to talk about why they have a headline that says hundreds of stars have vanished, and then they show a
Yes.
picture where stars are just behind a cloud.
Yeah. Click
Trickery.
that's just trickery. That's just to get clicks right there.
So we'll talk about why you show this in your classes, this cloud covering these stars. But can we talk about this, because I've got this thing about clouds, right? And I didn't see this coming. So let me just delve into my cloud business again. I
Go.
understand how water floats in the on the earth.
Yep.
Well, I understand the explanation for it, that somehow it has to do with lift and air thrusting up, but somehow water floats above our heads until it gets heavy enough to fall as liquid water, or frozen
Yep.
ice. Still a mind bender, and we should just, every time we look at the clouds, be like, water floats. Don't totally understand that. But you've got lift, and you've got an atmosphere, and you got what's going on out in space where dust particles are buddying up with each other enough to create a cloud that, from wherever this photo was taken, could block out the light from stars. Why is dust joining together out there in the vacuum that is space?
Excellent question. And first thing you got to realize is that this thing is a lot bigger than any cloud you've ever. I mean, this thing, you could put a million solar systems inside this thing. Okay. It's very large.
A million solar systems?
Tens of
Okay.
thousands,
I
a
don't
bunch.
care. No, if you say
Yeah.
more than one solar system, my mind is
Oh
blown.
yeah. Way more. This thing is several light years across. Okay. So it's very large.
Is this a
Okay.
real picture, or is this one of those?
This is a real picture. It
Okay.
is not doctored. It's not artist's interpretation or whatever. It's not. No, it's a real picture. I've seen this picture since the late '90s at least. I don't know
Wow.
when it was
Okay.
taken, but it's an old picture. Um. So basically, what holds it together is gravity, its own gravity. The attraction of dust
The
particles to
the
millions of
little
other dust particles.
the little teeny dust particles have enough gravitational pull to attract each other, or
Yeah. Yeah.
oh my God, I don't understand anything. Okay. I was truly under the impression, for gravity to really, like, work, you had to have some size. And now we're talking about particles of dust that are out
Dust.
in the
Yes.
universe, solar
Yes.
system somewhere, and now have found each other like lovers on a train, soon to have a
Yeah,
life
yeah.
together?
The visible the mass of the visible mass of the galaxy, like the of the
Okay.
Milky Way galaxy, it's about half stars and half gas and dust.
Okay. All right. This
So
is
there's a
helping.
lot, lot of gas and dust out there between the stars.
Wow.
And
Okay. So,
that's where stars come from. They come out of these clouds. They're born out of such clouds.
wow. Okay. That's gonna that could eliminate the lion lioness eating her cubs in my brain for the day. Hope
We
the
did it. We got it out
stars
of you. We got it out of
the
your mind.
the stars form by the dust. I would totally think it would go the other way, but okay.
Well,
And I
when they
thought
die, they
stars were
also
mostly okay.
when stars die, typically they throw a bunch of their material back out into what's called the interstellar medium, this gas and dust. They
Okay.
throw their stuff back out, and that can become new stars in later generations.
Okay. So that all that dust that's out there somehow. So why does like the edge of a cloud? I mean, that's not only my question up there in the sky. It's my question about our little sky here. Why the edge of that cloud? What if it's gravity and it's grabbing all this stuff? Like, why is there what looks like from, I don't know, so far away? If we're talking about light years across here in this photo, like it's forming itself dense enough to have like an edge to it. You see what I'm saying?
Yeah, yeah, and it does look that way from a distance. But if you've been on a plane and you've seen, when you get up
Sure.
closer to a cloud, starts getting. You see that bright edge is not nearly so well defined as you
Yeah,
thought.
good point. Good point. Good point.
Yeah,
Okay.
yeah.
All right. All right.
Same
Fair
thing here.
enough. Yeah,
Same
I'm a
thing
little
here. Those edges to this thing are, you know.
wow. So why do you talk about this in your class? What when you show this photo,
Well, we talk
what's
about the what's called the interstellar medium, this gas and dust, this that lies between the stars. That's a whole chapter or two in an introductory astronomy textbook, and this is just one of the more dramatic examples of this dust that absorbs light, and so that's why it's shown. And it's just and there's also other pictures of it taken in other wavelengths where you can see the stars behind it. You can see them shining through it.
like through it? What is the what are the looks on the you see the balloons right now? Did you
I
see the
did.
balloons
I
just
saw
float
that.
up over my face? The, this
Did you?
happens. No, I'm not doing anything, and this happens occasionally. Apple newest updates, both in your phone and your computer, has this thing where it's hand gestures that can like if you do a thumbs up, it'll put like a
Yeah.
thumbs up balloon or
Okay.
whatever.
Yeah.
It's only really supposed to work on FaceTime, but here on Ecamm, the thing we use every once in a while, and I've heard the same thing on Zoom. It happens. But this time I was literally just sitting still with my touching my face, which I do far too often. I realized
My
while
first
watching
thought
this movie.
it was because we said the word birthday about 20-30 minutes ago.
Yeah, that it was just like, hey, let's dig up. I don't know, but every once in a
That was
while,
cool
just
though.
fun random things happen, like balloons floating up or
Yeah.
little thumbs ups happen. Um,
Bigfoot will appear behind you in a minute.
no, now I have totally forgotten what I was even talking about on the. Oh,
We're
what
talking
are the
about
looks? What are the looks on the students' faces when you start describing this to them? Is it closer to the look
well,
on my face, or are they just like just
usually
grabbing their
what I
pen
do
and
when
looking down and writing it in their notepads?
well, it's funny what some students will ask at certain times, but with this particular picture, I haven't taught intro astronomy in several years, but I used to use this picture, and I would start off and I would say something like, "There's this really weird hole where there's no stars and nobody knows why,"
Yeah.
just to get their attention,
Like this headline, just like this
Yeah,
headline. Yes.
exactly. I do it just to get them out of their will this be on the exam mindset. Um, just to get their attention. I
Mhm.
say, but then I say, no, that's not really true. I'm just making that up.
It's a magic trick where it's just covered up. Um,
Yeah, yeah,
I guess this helps me just generally thinking about space because uh, I've been told and have chosen to, I guess, put the accent on this phrase when I would hear it, that space is mostly empty.
yeah. It is.
But then you're like, it's really also mostly full of gas and dust.
No, it's not mostly full. No, no, it's not. It's mostly
Okay.
empty. I mean, on the and when they say mostly empty, what they mean is if you averaged it out. I mean, there are places obviously where it's not empty. For example, my office right here is pretty full of stuff. But other places in the universe are very empty. And on the average in the universe, there's about one proton per, like one hydrogen atom per cubic meter.
Wow.
That's really not much of anything,
No,
right?
totally. Mostly empty with a little bit of
Mostly
dust.
empty.
Yeah.
Yeah.
Hey, how sure are they on this? What's the confidence level on the gravity to dust cloud things? Are we talking like no one really disagrees with that? I know in science nothing is
You mean that
certain, but
gravity is holding this dust cloud together?
uh-huh.
No, there's no question.
All right.
That's not something that has any uncertainty on it.
All right.
It's
Wow.
true. I mean, that's what keeps our atmosphere attached to the Earth. All the little air molecules in our atmosphere are being pulled, held onto the Earth by the Earth's gravity. If we turned off Earth's gravity, we'd lose our atmosphere.
Mm-hmm. Mm-hmm.
Boom.
Yeah, okay. Fair enough. And I guess the atmosphere here is also made up of tiny little particles that are
Yep. A
impacted by
lot.
gravity.
Yep. Yep. But the point in this case is that what you've got is a very large object, huge object, and so it's enough. Even though the gas is still pretty sparse in that, the dust is still pretty sparse in that picture. The thing is so large and so deep. From our point of view perspective, we're looking through light years of dust when we look at that picture. We're looking like along the line of sight. It's like light years of dust. So even though it's not very dense, there's so much
Oh,
of it that light can't get through.
got it. Okay. All right. So that's the photo part of this story. There's also the
Yep.
headline: hundreds of stars have vanished without a trace. What's that about?
Yeah. Well, basically, stars at certain points in their lives, certain stars at certain points in their lives undergo big fluctuations in brightness. Our sun is not
Mm,
doing that, which is good for us. Our sun is very stable in a very stable sort of midlife part of its life. Um, but some stars that are more massive than the sun end in supernovas, but those supernovas don't always happen in a nice gradual. I mean, the stars tend to flicker on and off and get
mm.
bright and get less bright at the end. They get unstable, and so their brightness changes. And so when they say hundreds of stars have vanished without a trace, that doesn't mean the stars have actually vanished. That means
Wow.
that sometimes we can see them and sometimes we can't, because sometimes they're above the threshold of what we can see and sometimes they're below the threshold of what we can see as they vary in brightness.
I mean, this is really a human centric perspective.
Right, right. Vanished from our perspective. They've come and gone. Maybe they've
Yeah, sure.
vanished, but
No.
they're still there. They're still doing their thing.
Well, all right.
But
So
they
so
mentioned
why is
this
it
thing.
why do you think this is a question then for an article and stuff? What are they getting at?
Uh, you know, I think that the science itself is interesting. The idea of these stars about to go supernova that vary a lot. That
Oh, okay.
I think there's a lot of interesting science there. But will they also throw a little science fiction in here? If you read the sub headline, it says explanations range from failed supernova to much more unlikely. I think I would underline and italicize the word much. Much more unlikely so-called Dyson spheres.
Okay,
Heard
here
of
we go.
that phrase?
No.
This is a sci-fi angle here.
All right, let's hear it.
Okay, the idea here is that a guy named Freeman Dyson, a physicist, sort of uh, one of these people that sort of thinks in kind of off the beaten path a bit.
Okay. Like the type.
Yeah, and he talked about like if we advance as a civilization and we wanted to have essentially a limitless energy source, what could we do? And what we could do is we could build a sphere around the sun to
Oh, yeah, okay.
basically trap the sun's energy, because the sun's energy is so it'd be limitless for us. Um, and so if we built one of these spheres, it
Mm.
could from a distance, block out the sun. Right. If we had something large enough to actually encircle the sun, that if we were a distant civilization looking back at ourselves, we would see our sun go out
Okay.
because this Dyson sphere would cover it.
So one of the options is, oh, these are not stars that have gone to supernova. These are some advanced civilization that's
Right.
created a giant sphere, and they're hiding
Right.
behind it, like hiding behind a dust cloud.
Exactly.
Oh my gosh, that's awesome. That's awesome. So he's like, "Oh no, 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 no! This is not stars flickering and burning out and going
Right. Right.
supernova." By the way, one of the great phrases that I'm surprised is not part of our just vernacular. Like, it was unbelievable. I was so in it, I just went full supernova. Like, why we
Yeah,
don't talk about that? That's
we should work on that. We should try to just bring it into our discussions here.
totally. This
Uh,
podcast is full
the,
supernova at this point,
yeah.
folks.
Yes.
Look
Right.
out.
Right. Right.
I mean,
And then eventually, that could catch on.
yeah. I think there's a band called. I'm sure there's a band called Supernova, but maybe one I've heard of. Okay, so his idea is no, what we're seeing out there with flickering, vanishing stars is proof that there's advanced civilizations out there creating power sources.
Right. I don't know if the proof's a bit strong, but that's what that's
How does that even get a hearing? That is that is remarkable.
yeah, yeah. But there it is. I mean, and it's. I mean,
Wow.
I give them credit for not putting Dyson spheres in the headline, and advanced civilizations. Do we have evidence of they could have put that in the larger headline, and I give them credit at least for not doing that.
Okay, that's gracious of you. I just counted. There are 24 words between the headline and the and the sub headline, and
Yeah.
2 of the 24 words are Dyson spheres. So it's 1/12 of all the words that are on this in the headline of this article are about that.
Yeah.
That is
And
that is incredible.
if you include the much more unlikely, then that's a much larger percentage of the words.
That's right. And uh, uh, are there people? I don't know. I don't want to keep you on the Dyson spheres too long, but
All right.
is there like a community of people around the Dyson spheres argument? Not only that we could make one if we need to, and I've heard about that. I heard some podcasts where they were talking about this sort of idea.
Yeah.
Um, but is there some little offbeat group of people somewhere in the flickering dark web that are talking about this, like, and have meetings and get-togethers like they do about so many other
There
ideas that seem
probably
so inconsistent?
are, but I'm not sure if
You don't
they're
know
really
them?
attached to any funding. You know what I mean? I
Yeah.
think it's just basically a science fiction
Okay.
group or something.
Yeah. Well,
I
there's a lot of those.
mean, there are offices, I think, at NASA who are charged with what we might think of as speculative ideas to keep pushing the boundaries. But I'm not sure that they're onto this yet. Because I mean, imagine where
Hang
would you
on a
even get
minute.
the material?
There's an office, there's a
I mean,
department at
I don't know if it's a
there's an
department.
effort at NASA. There's energy going into speculative
For
science
example,
ideas at NASA. That's awesome.
yeah, I mean, there have to. I mean, it's it's kind of like if you have a car company, there's always that group of people at the car company who are working on like these sort of versions of like Ford cars that are
Okay.
completely, what I'm saying, there's a word for them. It's like concept cars.
Okay.
They're just off completely unchained from like mass production and idea of selling this thing, but they do it in order to sort of test new ideas and
Well,
push
look,
the back.
if Apple TV or Amazon Prime has not been pitched a show yet about the people in the speculative science department at NASA, that is something that should
I'm not sure if there's a single
ex-
department named that, but there are people like who are
well,
coming up with ways to divert like asteroids. Like, how do you divert
Mhm.
an asteroid that's gonna hit the Earth? They come up with this thing called a gravity tractor.
For
A
sure.
gr Those 2 words I've heard separately, right, but together, gravity tractor, which is basically building a device that's large enough to gravitationally deflect an incoming asteroid.
Wow. And I hope in Einstein-like fashion, it's one word too. I hope it's not even two words. I hope it's, I hope it's like one word.
Yeah.
Well, look, I can already spec out the show on this thing. And whether it's true or not that there's a department, there's a separate little part of the building where these folks are. And there's one person in there and she's really on to something, but everybody thinks that she's, just part of that speculative group and they don't
Right.
give her anything. And she's, here's the premise of the story is to
Yeah.
follow the life of her, and then the cast of characters that are in this, and then all the straight laced scientists that won't listen to the
Right.
truth about all these
And
things. Oh,
and
lovely.
you've got, like, at major scientific labs, like at Los Alamos, right? They've got people doing theoretical stuff that is just completely it's just, you know, it's like they pay people to sit around and think and to I mean, they're not just average people. These are like,
Yeah.
but, I mean, the theoretical division of Los Alamos, right? There's some crazy stuff they're thinking about,
Wow.
because
They need to make this popular culture. All right.
they should.
Well, I think we had a couple more things. 4.5 billion years ago or so, another planet crashed into Earth, and we
Mhm.
may have found its leftovers. Now, there's another just fabulous headline. A great photo for people that aren't looking at it. Like there's an artist. I'm sure this is an artist rendition and not a real photo.
Absolutely.
Fair enough.
Yeah, absolutely.
uh, it is just it's just crazy looking. Um, I've heard of big things crashing into the earth. And I think we even had a conversation where there's a theory that the moon was the split
Yeah.
off of something crashing into,
Yeah.
and I can't remember if that was speculative or if
And when I first saw
that's what
this
people
this
think.
when I first saw this headline, my thought was, "Yeah, we found the leftovers." You see it every night because it's the moon.
So
That's
so
my first
so the
thought.
idea that the moon is a spit off of something colliding into Earth, th- that's something that's true, or that's something that's
Yeah, that's
in
something
my
that
memory.
let's say it's probable.
Fair enough. Fair enough. You got a
Getting
formula
back
for
to
that.
the probability discussion we had earlier.
Which
Yeah,
is
it's
pretty
probably
freaking cool.
wrong.
I honestly, it seems so fascinating and so like spot on and cool to me that I couldn't remember if it was just something we talked about, like a Dyson sphere,
Right,
or
right,
if it was, you know, something
yeah.
more
But, I
real.
mean, you have to remember that 4.5 billion years ago, collisions between large solar system bodies were super common. It wasn't like this weird kind of freak accident. It was like these collisions happened all the time.
And again, the reason was more then and not now is because of the expanding universe
No, it was because
fact.
the solar system was formed out of one of these clouds of gas and dust, like we were talking about earlier. And the planets slowly accrued out of these smaller particles, rocks, boulders, and so forth over time. Um, and so during that process, these massive objects were colliding into other massive objects. Why were they colliding? Because they're gravitationally attracted to each other. And so they were built up slowly over time. So these kinds of collisions were much more common
Hmm.
all
Hmm.
the time. I mean, that's how the Earth was built up. That's how all the planets were built up, was out of numerous collisions and the
Right.
accruing of these smaller.
And I guess when we think, well, like we don't really hear about that now, or other planets aren't crashing into the Earth, that's just because our human time on this Earth, of keeping
Right,
records of things is like 6,000 years of keeping
right.
records,
Yeah, the solar
and
system
that's
was largely cleaned out billions of years ago, but it's still not totally cleaned out. There's still asteroids, right? That are
hmm,
near Earth asteroids, and we got the asteroid belt.
okay.
We got billions of asteroids.
What
So
what
it's not really cleaned out yet, but it's much more cleaner. All the crap's been vacuumed up mostly by the big planets.
Pretty cool too. Hey, what did they say they found here? Do you have any idea?
I don't know. I'm sorry to say I did not read the
Yeah, yeah.
article. no, and I'm not sure what they found or what collision they're talking about.
A planet.
Yeah, that's the thing. Another planet. Yeah, that's actually different than another
Yeah, that's
planet.
different to me because I was like, okay, I've been, I'm doing my schoolwork and I've been trying to understand what makes a planet because it's
That's
still
a little
pulling
bit.
for Pluto.
My response to that, and again, I haven't read the article, but
Oh, you don't need to.
is that it's calling another thing another planet. I mean, at that point,
Yeah.
I mean that's when the Earth was formed 4.5 billion years ago. So
All
it's
right.
not clear maybe at that time what was a planet and what wasn't. Do you know what I mean? It was such
Yeah.
a mess. The solar system was such a mess. It might have been hard to identify what was a planet and what was not at that
Sure.
time.
And by current definitions, what is it that makes a planet a planet?
Three things: it's got to be orbiting the sun. It's got to be large enough to have pushed itself into a spherical shape. Only certain objects of a certain size are massive enough to crush themselves into a spherical shape. And the third thing is that it's got to have essentially its orbit has to be empty of everything but itself.
Hmm.
So, like a large asteroid doesn't count because, like the large asteroid Vesta, for example, is not a planet. It's spherical and it orbits the sun, but it orbits with a jillion other asteroids in roughly the same orbit, so it doesn't count.
Got it. So we don't call that a planet because it's in those
That's why
conditions.
Pluto was demoted because Pluto orbits out beyond Neptune with thousands upon thousands of other objects,
Oh.
and Pluto's not even the largest of those objects.
Hmm.
So
Um, so it seems a little odd then that a planet would collide into another planet if it's supposed to be in an orbit by itself. Like that just all
right, and
feels
that's why I'm saying that you might not be able to call that a planet.
okay. Well, whatever. It's just the idea that something crashed into it and now there's stuff still around and
Yes.
is is a is a fascinating I mean, talk about your climate change. We're talking
Yeah.
serious climate change. When there was an earth
And very
hey,
sudden.
when there was an okay, I'm going full screen on this one. When there was an Earth without a moon, because it hadn't been collided into
Yeah,
yet,
yeah, yeah, okay.
feels like the moon is a really important feature in the gravitational flow of the Earth. You hear this thing about tides and all this
It's
stuff.
hugely important. Not only do we get the tides from it, but the Earth's or axis of rotation is stable because of the moon. The moon serves to stabilize the Earth's axis of rotation, which means that our seasons are regular, predictable, and really don't change much.
Yeah, and things aren't wobbling all over.
Right,
So,
exactly.
an Earth without a moon, uh, I don't know, like,
It's not clear that we would have life on the Earth without the moon.
hmm,
It, it may be that the fact of that we have the moon and the fact that the moon is the size that it is was one of the long list of things that are required for life as we know it.
Joanne asked this really
So
great question. I know you have an answer for it because I feel like you've explained it to me before. But why do planets and stars have spherical shapes after these collisions, where asteroids are all kinds of shapes? So,
yeah, some asteroids are all kinds of shapes. It's really all that matters is size. Size matters here, and
hmm,
that's the only thing that matters is how large the object is. Smaller asteroids are all, they got all kinds of weirdo shapes, just like she
okay,
said. She's exactly right. They shape like potatoes, shaped like pinball machines, shaped like, whatever, just weird shapes, more or less randomly thrown together shapes.
yeah,
But once you get beyond about, I don't know, let me guess, 50 miles across, something like that. This is the ballpark. There is a line. I can't remember exactly where it is, but let's
okay,
say 50 miles across. The gravity of the planet, the self gravity, because that's what keeps the Earth together is just gravity. Okay. The self gravity of the object is so strong that it crushes itself into a spherical shape, because that is the shape that in which every bit of the planet is closer on the average to every other bit of the planet.
there's something about a sphere, an
Yeah,
oblong sphere that
it's
this
an
is
it's
as close as the particles can get to each
right
other.
on average. Yep, yep. if you've got all the pieces of the Earth, imagine breaking the Earth up into a billion little pieces, and you want to ask yourself, how can we arrange these pieces so that they are on average closest to each other? That would be a sphere.
Hmm.
So that's and gravity is that's effectively what gravity does. Gravity is always pulling things together. Gravity wants things to be as close together as possible.
Ah, I like that. I like that. Gravity's just all about closeness.
That's it.
Gravity's
Yep.
like grandma at Thanksgiving. Just can
Yep.
we all come into the house? I know it's crowded and sweaty in here, but can we all just climb on in? That's gravity.
Let's get close. Yep.
Let's okay. So enough size because somehow gravity is related to size, which again is my
It's related to the distance between the closer two objects are, the stronger
oh
they pull together.
boy, there's another little emotional life lesson.
So many.
The closer they are, the more they pull together. The dust
Right.
clouds still. These are the
Exactly.
things I
That's
thought I knew,
exactly
and this is
the
where the
thing
dust cloud
that
gets a
dust
little
cloud. Yep.
confusing for your
You're
friend Bart.
connecting the correct dots here. Yep.
Yeah, I'm getting a little confused about that. All right. One last quick story, and then we'll do some other questions people have. The planets, Jupiter this is the headline. The planets, colon, the use of a colon. Jupiter reaches opposition and other must-see events on the solar system. When I sent this to you, you said, "Oh, I totally understand what that is." I've never heard the phrase opposition related to any of this because I'm not an astrophysicist.
Sure.
But what are they talking about? Jupiter reaches opposition. And
All right.
what is it and why does that matter?
Well, it matters. Let me ask you this: have you ever seen a full moon rising? And when does a full moon rise? Do you know? Do you know,
I've seen a bad moon rising. I don't know that I've ever seen a full
Okay.
moon.
A full moon rises at sunset, always.
Okay.
Okay. Because it is opposite the sun in the sky when it's full. It's got to be. The moon is at opposition when it's full. It is at the point in the sky directly opposite the sun.
So they're using the term here, opposition, to mean opposite position kind of thing,
Yes,
like the
it's opposite position of what? The sun. So Jupiter's at opposition when it's 180 degrees away from the sun. So if the sun's setting in the west, Jupiter is rising in the east when it's at opposition, directly across the other side of the sky.
Huh.
I'm actually pointing east. That's why I did that.
Well, wherever.
Yeah.
Yeah, east from where you are. West from where somebody in, Beijing
Correct.
that's watching this is.
Yeah.
Okay, so so this is a big deal that now in the rotation of things now Jupiter is.
Well, yeah, there's a couple things about it. Number one is we're closest to it. It turns out that the Earth is closest to Jupiter at opposition as well. And Jupiter stays up all night long.
Wow, like a party kid. Mm-hmm.
But there's another song there you could reference as opposed to
Bad
Moon Rising. Exactly, you got Bad Moon Rising. Yeah. So basically, when it's in opposition,
I got a next open mic song set coming into form here.
So basically, when it's in opposition, it is brightest. It's largest in the sky. Because it's closest, it's brightest, and it looks larger on the sky. And also,
how long do we get Jupiter in opposition?
I mean, technically speaking, it's only for an instant, but practically speaking, it's for a week or so.
Oh, right. And nowish, like if people look up in the sky, they're going to see a big.
If you look west at sunset and you've got a clear horizon, you'll see Jupiter coming up. Yep.
Really? Wow. Hey, that's a nice little note.
There you go.
I mean, that's a nice way to finish all this conversation, right? Everybody goes out and looks west at sunset when you can, which now around here, right?
It's like look, I'm sorry. Look east. Look, I said west. I meant to say look east at sunset.
Look east, young man.
Just like the sun rises in the east, all the stars rise in the east, and so do the planets. So the Jupiter's coming up in the east at sunset tonight. So look east with a clear. You have to have a clear horizon, though. Pretty clear horizon.
It sounds like another song.
I'm sure it is.
Why do all the planets have to rise in the east?
Because the Earth rotates that direction from west to east.
Okay.
Yep, that's it. That's the only answer, because we're, you know, it's not the Jupiter rising, it's us being rotated so that we can, so Jupiter's within our line of sight. So
because it's
Earth
only on
rotates.
that side. I'm pointing east, so it's only on that side. It's not over on that side. So we rotate around, we see it over there.
The Earth is in the way. The Earth gets out of the way, in such a way that things rise in the east, because it's rotating west to east.
So we look east, and if you see something, what is Jupiter going to look like to an average person? You know, if Kimberly goes out here, you know, in Minnesota, and she looks east around sunset, which is going to be like between 4:30 and 5 o'clock here.
Yeah.
Like
it looks like a bright star.
Oh,
it won't flicker quite as much as stars do. You know, stars, especially on the horizon, twinkle. A planet won't do that as much. But it's almost directly east, and it would look like a pretty bright star.
You're not going to really see a shape of it or something like you do.
No, you can't see the red spot. You know, you can't see all the moons and all that.
Jupiter.
But it's just a bright. Yeah, no.
Is this a big deal for people? Are there people who like have religious communities or stargazing communities, do you know, that gather together around
it's a big deal
of Jupiter?
It's a big deal for, you know, for hobby skygazers, you know. And sometimes it's useful for people who want to make observations of Jupiter, because it's up all night long, so you have all night to look at it. You know, if you've got a ground-based telescope looking at Jupiter, opposition's a great time because it's closer. It's brighter, and it's up from dusk until dawn.
How often does it go into opposition?
Jupiter goes into opposition. I'm gonna go out on a limb here and say once every 1.5 years, maybe 1 year and a few months.
Okay.
So I want to guess 1.1 year. So every 13 months or so, 13 or 14 months.
Yeah.
So it's not that uncommon. It's not uncommon.
Yeah. Yeah, but it's a thing people are going to see and notice. Hey, do you have time for one more question? Yabbit says, has a question. Is there a core to the moon that's hot?
I suspect, I don't really know much about that, but I'm trying to think back to my last time I taught. I think that the core of the moon is still warm, but I wouldn't say it's hot like the Earth's core is hot. If there was a lot of heat inside the moon leftover heat from formation and all that, then we would see evidence of it on the surface. There'd be some kind of tectonic activity, or there'd be some kind of volcanism or something, but there's nothing. Like, the moon is dead geologically, so
it's not broiling around in there.
Right.
How would it have gotten a mantle hot core if it was just a chunk of Earth that went flying up in the air and that was big enough to form itself into a sphere by gravitational power?
Two things, really. The Earth's heat comes from two things. One is what I call the heat of formation, which is just basically when you take a bunch of rocks and throw them together really hard, they get hot. And so they just get hot from the friction, from the crushing them together. Just the friction is the right word. But also there's a lot of radioactivity inside the Earth that is not yet finished. It's still uranium and so forth that is still decaying and creating all kinds of heat.
So a little bit of that could have pumped up to the moon and taken it.
Yeah, but the moon is a smaller object, and so if you imagine you've got two hot potatoes in the oven, one's big and one's small, you pull them out, the small one's going to cool off a lot faster than the big one. So the Earth is not quite cooled off all the way.
So is the Earth going to cool off too much to stop life before the sun burns out? Which cataclysm is coming our way?
I don't think it's going to bring an end to life, but it might bring an end to plate tectonics. It might bring an end to volcanoes. But I think I don't think it's going to bring an end to life. I don't think that is necessary for the sustaining of life. But it might be necessary for the beginning of life.
Wow. Okay. And there's something about the electromagnetic pulls that have to do with all this mantle business, right? Because doesn't that shift at some point? Aren't they afraid that's going to happen? I feel like in one of the podcasts
I think
6 or 7 years ago we talked about
every 250,000 years. No, the Earth's magnetic poles reverse every about 250,000 years.
And we're due, right? It's like changing your furnace filter at the winter.
I don't know when the last one was, but it doesn't happen like, oh, we wake up the next morning and all our compasses point south. It happens over 10,000 years or something, which is a blip on the big picture, but for us, you would barely even notice it.
Okay. Hey,
over a lifetime, you would notice the difference.
I will do one more if you have time for it. Alex asks, do we have the capability to deflect or destroy large objects headed for Earth? She just saw Armageddon again. Loved it again.
Well,
is curious.
We don't right now, but we're working on it. We just had a mission that deflected a small asteroid.
Really?
Didn't we? I thought we talked about that.
I don't know. I have no
Maybe I talked about it with some other person named Doug. I don't know.
you remember things based on the name of the person you're talking.
Yeah, it's weird that way. No, that's actually a good question for next. That's a good question for next time. I'd like to look up because it's happened in the last year or two. I'd like to look that up because that's an interesting question for everybody.
Well, Kimberly agrees. She learned that on the news.
Yeah. So in other words, Kimberly, I think that that we're testing that, and I think we're able to deflect small asteroids a little bit, but truly harmful sized asteroids, I'm not sure if we've gotten to the point that we can do that. But I think we're testing. We're starting small and working our way up. And
this needs to be a teaser for whenever we talk about this. But
yeah,
are they using lasers? Are they using sound waves? Are they using nuclear blasts? What are they doing?
It's a brute force impact and an explosion that
just bam over and over. Yeah, just like human beings colliding things into other things in order to get the outcome
demolition derby in space, basically. Yeah.
Unbelievable. Paul, thanks for all this. All of you in the chat, Kimberly Yabbits, Joanna, Love and Life, Jim, all of you that are always part of this. We appreciate it. And
thanks everybody.
Say hi to the students.
Oh, I will.
Okay. Bye.
All right.